Right, finally, Chapter 9, the assess. This is question 4. What is the order of rotational symmetry of this shape? Well, let's just take a look. From there to there, 1, 2, 3, 4. It goes back on himself, so it's order 5. What is the angle of the rotation? Well, if these were perfect straight lines, so let me try and do that a little bit. Let's work a little bit darker. So if that was like straight from there to there and there to there, for example, then you're looking at 5 of these lovely angles. So if we take our 360 degrees, which is one complete rotation, divide it by 5, that will come to 72 degrees each angle of rotation. So if I put a 72 there, then that's fine. Alright, next one. Copy the diagram. I've done it all. I've just pasted the grid onto the screen. Rotate the shape 90 degrees clockwise about the origin. You may recall origin is the coordinates 0, 0. And let's just try and do this, shall we? And try and do it a little bit thicker than that. And we'll do it in red so it stands out. So 90 degrees clockwise. If I'm going to imagine this line here moving 90 degrees in this direction, I know it's going to end up right there. Okay, so it even looks like 90 degrees, doesn't it, going clockwise like that. So following the rest of the shape, 1, 2, 3, 4, 5 squares. I'm going to come 5 squares across here like so. Again, not perfectly drawn, but 1, 2, 3, 4, 5, and then take it back home like that. So that's the shape, gone 90 degrees clockwise, so that's gone meow like that. 90 degrees clockwise. And that's that. It doesn't ask me to give the coordinates to the vertices. I could do that. Don't need to do that. Please note that is 90 degrees to that. That is 90 degrees to that. And this last one here is definitely 90 degrees to that. So it looks right. It is right. It's very easy rotating from 0, 0, especially if one of the vertices of the shape is actually sitting on 0, 0, which it is right there. So it's really easy. Don't need tracing paper for that. Right, next one. Describe the translation that maps A onto B. There's that word maps again. It's very good. In other words, how do you get from A to B? You're not allowed to say go right 1, 2, 3, 4, 5 and go down 1, 2, 3, 4. I want to give it as a vector because this is a grade C question. So there's my column vector. So if we pick a leading point, if I want to pick this one, say I want to end up there. How should we do this? 1, 2, 3, 4, 5 to the right, so it's positive 5, and then 1, 2, 3, 4 down, so that's minus 4. Check again. 1, start from here. 1, 2, 3, 4, 5. 1, 2, 3, 4. So it's 5 minus 4, and that'll be a 2-mark question. Alright, so translation vector maps A onto B through the vector 5 minus 4. Next question. What is the equation of the line of reflectional symmetry? In other words, the line of symmetry that maps A onto A dash. So this is the original object, this is the image. So let's just use those words, object, and we'll use the word image. Well, so much for the words. It's right down the middle there, and you may recall all the vertical lines are x equals something. So there it is. Just draw it down there, and you should know that is the line x equals 2. There you go. All the coordinates on that line have an x value of 2. 2, 6, 2, 3, 2 minus 3, 2 minus 4, etc. That's the correct line. X equals minus 2. Turning over, we've got this one here. Copy the diagram. No. Write down the coordinates of the vertices. Okay, let's just get a couple of marks. So that one's going to be minus 2, 2. That's going to be 0, minus 4. That one's going to be minus 5, minus 1. Right. Reflect the triangle in the line x equals minus y. Terrible. It should be y equals minus x. That's exactly the same. It's like me bringing the minus y over and plussing it. So I get y plus x equals nothing, then taking the x over and subtracting. Hence y equals minus x. Besides, if you know anything about y equals minus x plus c, y equals mx plus c, then that's the general equation of a straight line. And this is quite a special one, but it's still a straight line. Therefore, let me draw in that line for you, then we'll worry about the reflection in a minute. So, if I want to go from minus 6, 6 to 6 minus 6, it should pass straight through the origin. Beautiful, love it. That is the line y equals minus x. It's so pretty, I'm going to label it for you. Y equals minus x. Now it's not so difficult trying to reflect in that. So I'm going to use my line facility and go red. Right, let's just try and do it visually. I think that's correct. 1, 2, 3, 1, yeah, 3. And this can be quite tricky, this bit, honestly. If that's there, then that's going to end up over here. So I reckon that's going to be right there. Going across there, yes, that's good. And just join the ends, go back home again. We'll study that. That is a lovely reflection. So 0 minus 4 becomes 4, 0. It's just interesting, this. So minus 5 minus 1 becomes 1, 5. See, there's a connection there. And minus 2, 2 remains as minus 2, 2 because the shape is actually touching the mirror line, the line of reflective symmetry. And so the point minus 2, 2 is also shared with minus 2, 2 of the image as well. So let me just write down the word image as well. And this image will be called A dashed because it's the image of the original A in the question. Don't think there's any more. So that's it. So that's the essential ingredients of rotations, reflections and translations. Again, I'm sorry I can't do the rotations very well. We'll do it in class with tracing paper. We'll have a lot of fun and then we'll understand it better. Again, I will of course trawl the net for some other YouTube videos which other people have done, and if they've used, you know, tracing paper working on a wooden table, then great. If not, then we'll just do it live in class. Either way, we'll get it. Alright, don't worry.